Well, it's that time. We're going to be doing the timing belt, water pump, accessory belts, radiator, thermostat, and all coolant hoses on this beautiful 1994 Miata. Car's got just shy of about 56,000 miles on it, but the radiator is original, the water pump's original, the timing belt. None of this has ever been done to this car, and it really should be done. It should have been done a long time ago, just because of its age. So, one of the critical steps that they suggest, that everyone suggests, and they can suggest anything they want, doesn't mean I'm going to do it, is you should flush the cooling system. I'm not in the mood to do that. I don't have the facilities to do that, and I don't want to pay someone to do it. So, I'm just going to drain it. We're replacing almost the entire cooling system anyway. So whatever. I'll take my chances. And the reason they suggest that is because it's good for the new water pump. Well, that's all well and good, but I'm not doing it. So anyway, what I'm going to do is we're going to drain out the old coolant first. Okay, so to recover as much coolant as we can, I picked up this low profile drain pan. Now we're gonna have to pull the bottom cover off. Just a couple of 10mm bolts. That's what. There we go. We'll do that. So 10mm, and then it'll drain that radiator completely. All right, so let's get a couple of questions out of the way. Number one. This is not a how-to video. You will not learn how to do a timing belt from watching this video. In fact, I left a lot of footage out just because I had to speed things up a little bit as I was losing daylight rapidly. Number two, no, I'm not a professional auto mechanic. I have no training. My father, however, was a Nissan mechanic for many years, and he worked on vehicles all my life, as long as I've known my father, which is my entire life. So I've worked with him on a lot of projects, and I've done a lot of them on my own. I've done my own timing belts, water pumps, radiators, head gaskets, all the things that you would ever expect to do on an older vehicle I've done. Entire engine swaps even. I've done 2 of those. So I fortunately have a little bit of a mechanical background besides this. Number 3, timing belts are one of those. A timing belt is a major service for a vehicle like this, and generally requires removing a lot of other components to access. And the stakes are very high on many vehicles. You can blow the engine. You can destroy the engine if you do the job incorrectly. Fortunately, a Mazda Miata is one of those rare birds that uses an engine that is a non-interference engine, meaning that if you really screw the job up, you will not damage the engine. Unless you have severe detonation because you've got the timing wrong and you repeatedly try to start the vehicle, you could potentially damage it. But it's a very low-stakes operation on a vehicle like this. So what we're doing right now is we are removing the splash shield so we can gain access to the radiator drain cock. It'll also give us access to the alternator pivot bolt, which can only be accessed from below, and it will also allow us to remove the lower radiator hose, which can only be accessed, of course, from below. Again, this is not a how-to video. This is just a kind of overview of what I had to do and what I encountered doing the job. There are plenty of resources online for doing the job right. In fact, I highly suggest even using the Haynes manual, which is a very inexpensive service guide for these vehicles. Haynes manuals are very broad-based. They are not as good as a factory service manual, but for doing routine maintenance, they usually provide all the information you need, such as procedures, torque values, and really just the basics. So let's get that drain cock removed, and that will allow us to drain the radiator. We've removed the radiator cap first, so the fluid should come out fairly easily. I'm not sure if I mentioned this earlier, but you also want to make sure that your engine is cold while doing this job or before doing this job, because you don't want to drain hot coolant from a hot engine, which could cause the engine to suddenly decrease in temperature more rapidly than it's designed to. And in some cases, you can even warp the cylinder head or damage the head gasket. So this engine is stone cold and hasn't been run in over 24 hours prior to doing this. I would say the engine should be cool to the touch, but that's just my own belief on the matter. So if you can hold your hand to the cylinder head, you should be okay. Okay, with the radiator now freshly drained, and look inside. Oh my God, this radiator's in perfect condition internally. Damn, it's like brand new. Okay, once and for all, why are we changing out a radiator that doesn't leak and has no visible signs of corrosion at all? Well, this is based on information that I've gotten from other Miata owners and forums, and that when the radiators begin to turn green or brown, it indicates the plastic tanks are beginning to weaken from repeated heat cycles. And as I do understand that plastics generally become brittle over time, what can happen is on a radiator that is at the end of its lifespan, so to speak, can rapidly rupture. I've seen pictures where the tanks have actually shattered suddenly, and I'd rather not take that chance. So for $70-some, I bought myself a CES, I believe, radiator. The name is on the box in the beginning of the video, but it's an American-made radiator, not a Chinese one, and appears to be of similar quality to the original equipment. In this scene, what we're doing is we are removing the PCV valve is on the other side over there. That is some kind of crank vent, anyway, because we have to remove the valve cover. We're removing the valve cover because we're also removing the timing gears and seals. We also have a leaky valve cover gasket. It's leaking over towards the rear of the motor by the crank angle sensor, which is that little, right by the dipstick. See where the dipstick is? That big yellow thing? Well, it's leaking from there, and so we got to remove basically the entire top of the motor, and we're going to change out all those seals, and we'll be in there pretty soon. Alright, at this point, we're going to start removing the upper radiator hose. Now, this vehicle has never been messed with by anyone, so it still has its original equipment manufacturer spring clamps on all the radiator and other associated hoses. Now, these clamps are fun because you just basically grab a pair of pliers. I'm using needle nose pliers, and you squeeze that clamp together, and you can slide that clamp away from the fitting and just leave it on the hose, and you can even reuse them later on if you need to. But just as an FYI, I bought an entire hose and clamp set from Mazda for this car, so we will be replacing original clamps with brand new versions of those same clamps, which I do that to keep the engine looking factory. But anyway, that and these clamps really work well because they never need adjustment or tightening or anything. You just unleash the clamp and let it do its thing. Anyway, a couple of tricks that I found over the years to remove hoses from the water necks and thermostat housings and other fittings. What I'll do is I'll remove the clamp, and then I'll grab the hose with my hand, and I will rock it back and forth, and it'll eventually break the hose free. Now, there was one hose that I replaced. I didn't get this on video, but it's below the airbox. That hose is a pain in the neck to get to. There's really not a lot of room to work in there. To remove that hose, I ended up cutting the hose with a utility knife, just slicing it, trying not to dig too deep because you don't want to scratch the fittings themselves because they can leak if you do. And then I split the hose apart with a screwdriver and I removed it. The thing is, these hoses can often corrode right to the fittings, and it makes it very difficult to remove. if you have a European vehicle, the Europeans, I believe, were the first to do this, and now everybody does it, where they went to a plastic fitting, plastic couplings and hose connectors. Those are kind of a pain in the neck because often on a job like this, on a vehicle that's as old as this one is, those are going to be in need of replacement because over time they actually can deform and leak and warp and crack, and it's just no fun. But we have all metal fittings on this engine. This is an old Japanese car, and they built them pretty well back then. So now, as a side note, I noted that the hoses were in pretty poor condition. They looked okay from the outside. Yeah, see that one right there? We got to get that one from below. We'll do that in another segment here. But these hoses were in pretty poor condition once I got them off. But without doing that, they look just fine otherwise. So now we're going to take a pair of channel locks and we're going to gently rock this hose. You don't want to squeeze those fittings too tightly because you can crush them or bend them, and that's even worse. And that's like the worst thing you could ever do. So when you see me put channel locks on a hose like that, I'm not putting really any pressure on those channel locks. I'm just using them as something to grip onto the hose, and then I'm rocking it very gently to break it free. So I got the radiator unbolted at this point, and we're going to get ready to disconnect the fans, and we're going to pull it right out. Simple, simple. Fans and all. You want to leave the fans on there because it makes it a lot easier. Okay, we got the radiator out. That wasn't so bad. You just really have to undo everything underneath just to get it out. These are the refrigerant lines. The evaporator, or sorry, condenser stays where it is. Okay, tech tip for the moment here. So while those belts are still taut, it's a good idea to loosen up the water pump pulley, the 3 bolts that hold the water pump pulley in place. Just crack them loose. Don't take them out. Just crack them loose. And then proceed to loosen up your accessory tensioners. That would be the alternator tensioner and the power steering pump tensioner as well. That's assuming your car is equipped with power steering. Remember, the Miata could be ordered without power steering and without air conditioning, so you may not even have that other belt at all. Now what we're going to do is remove the valve cover so we can gain access to all the other goodies we need to get access to. And we're going to pull those spark plugs out. Make sure that you know where they go back. Mine are numbered 1 through 4, so I don't have to worry about not only that, but they're cut to length, so it's no big deal. I'm going to get those out. I'm also going to remove the number 1 spark plug so I can confirm the number 1 top dead center position on the crank. But turns out that was totally unnecessary. You don't need to do that. One thing you want to make sure you do is when you loosen up the valve cover bolts, they have to be done in sequence to prevent warpage of the valve cover. At least this is what I've been reading. It's definitely important that when you're torquing it back down again, that you also make sure the sequence is correct. I've heard of people breaking valve cover mounts before. I've never had it happen to me, but just because I've never experienced it doesn't mean it's not possible. Anyway, it's around this point my neighbor decided to show up. In fact, I met 3 neighbors that have lived near me for years who've never said anything to me, but when there's a guy working on a car in a driveway, everybody wants to know what's happening and what kind of car it is, what year it is, and where'd I find it, how much I paid. Yes, that too. Meet a lot of people that you don't really ever expect to meet when you're working on a car in your driveway. But that's life, and it's fun, and that's okay. Okay, so we are getting down into the nether regions of this car. Look at how clean this engine is inside. It's just amazing. This car was well cared for. This timing belt, definitely no good. The tensioner, probably one of the bigger problems here. It is making tensioner noise, which I don't like. Looks like there's 2 tensioners in here, and I believe they are bad. But yeah, I gotta get these. Now, one of the things I'm doing as I take this thing apart here is
I check for bearing noise in the water pump or the power steering pump, AC clutch. Everything looks nice and free. Yeah, so we're getting there. Prior to removing the two belts, I loosened up the water pump pulley just to get that loose while it's under tension. Now, to get to the crank pulley, we actually need to drop the sway bar. That's actually not that bad, as long as the car is not on jacks or on one jack stand. The car has to be on level ground. You can unbolt it from both sides and it'll just drop out of place.
To make the job easier, I bought myself the Flying Miata crankshaft holding tool. What it does is it allows me to not only loosen but torque down the crank bolt with relative ease. It's just a thick piece of metal that bolts right onto the crank pulley. And what you want to do is when you're bolting that tool in place, use the water pump bolts, not the crank pulley bolts, because they're shorter. And then you grab yourself just a simple breaker bar and place yourself firmly against the fender. I would suggest putting a towel between your body and the fender. That way you can you won't scratch the paint with any buttons or any dirt that might be on your clothes. And then just give it a good pull. The bolt is tight, but it wasn't as tight as I expected it to be. But you'll see me brace myself into position and crack that sucker loose. It wasn't really as hard as it looked. Yeah, but as I was saying, when you do this job, you want to drop the sway bar because it gives you a straight head-on access. And actually, I guess if you were to use a short socket, you'd be okay. But anyway, I didn't have any short impact grade sockets, so I used what I had. And removing this, just dropping the sway bar down, just make sure the car is on level ground and not, like, let's say you have one wheel supported on a jack or something like that. Just the point of that is you want to make sure that bar is not under a load at all, and that bar is only under any load or stress when the car is on unlevel ground. So just 4 12mm bolts and drops that sucker right out of position. You can do your work and you don't have to worry about it. So getting back to the theme of loosening stuff up while the belts are still on, we've just loosened that crank bolt. We did not remove it yet. Now we're also going to do the same thing with the timing gears, and all I'm going to do is crack those bolts loose. I ended up using an electric impact while everything was still good and tight. You want to just loosen those up. You don't want to take them off, because what we're going to do is we're going to get the engine at top dead center, and we're going to line up our two timing marks before we take any belts off. And then we're going to lock the camshafts into position with 2 adjustable wrenches, as everyone seems to be doing with these motors. So stay tuned for that. But we're not going to take anything off yet until that engine is locked into position and isn't going anywhere. So I'm going to share with you a story of one of my first timing belt jobs. I was 15 years old and I was working on my 87 Volkswagen. It was a single cam 8-valve engine, so pretty easy to work on, but it had an intermediate shaft that drove a distributor. And not knowing what I was doing, I just started taking things apart. I took the timing gear off, I took the belt off, I took the intermediate shaft completely out of the engine. I mean, I didn't need to, but I just did. It took me and my father hours to get that engine timed correctly, because I forget the exact reason why, but for some reason there was some peculiarity with that motor. I almost did the same thing, by the way, with my 16-valve Mazda 626. And that was a few years later. But I tend to make the same mistakes over again. And, yeah. So it's better to keep the engine in time. See, there we go. We're getting that impact going. So keep the engine in time while you're doing the job. That way you don't have to mess around with cam position, and it makes the job that much easier. Can it be done? Yes, it can. You can take those gears off and let the cams roll wherever they feel, but it just makes the job a lot easier to keep everything locked into position while you're getting that belt on.
What all the manuals or online resources tell you to do is take a couple of adjustable wrenches and lock them onto the, before you really start getting yourself into some trouble, you want to lock these camshafts into position so that they cannot move independently of one another. You want to keep them in line as much as possible. Use a cheap clamp and some crescent wrenches, and you got yourself cam lock. There we go. This will prevent these cams from going all helter-skelter and, you know, losing their position. But that is the redneck way, I guess, of building yourself a nice functional cam lock, and our gears are nice and lined up. Nothing is moved. Everything is where it should be. All is well. Undo the tensioner. Just to be undone. Little spring thingy. Get this belt out of the way here. Yeah. Okay, so one of the tensioners, one of the tensioners or idlers has a tensioning spring. The other one is stationary, so you've got a fixed position and an adjustable. Okay, let's see how that goes together. Okay, now we're going to check the bearing on this one. It actually seems pretty good. Okay. At this point, the timing belt is no longer under any tension. It's not much holding it in place at all. There we go. Tensioning spring. And the idler. How about this one? No, this one seems pretty good too.
But don't worry, we're not reusing any tensioners or springs or any of those things. I do recall hearing a slight bearing knock from this engine, which did in fact go away when I did the timing belt. Though if you look closely at those tensioners, I wish I focused on this. It's pretty obvious that the grease from those sealed bearings and the tensioners had actually started leaking out and coated the inside of the lip of that tensioner, both of them, in fact, with grease. So you never want to reuse those. You should never reuse timing belt tensioners. Yeah, some people will say that they can go for 2 timing belts, but is it really worth the hassle of having one go out halfway through the life of a timing belt that you just paid $500 to install? Depending on the engine, it could be even more than that. My motto is, things like tensioners that you have to remove the world to get to, just replace them. As a matter of fact, the Gates timing belt kit that I bought for this car came with 2 brand new tensioners and tensioner spring. So, hallelujah to that. So now we're going to remove a couple more hoses from the thermostat housing so we can remove the belt. Those hoses will be replaced along with the clamps, which I am destroying. Ay, ay, ay. Anyway.
Alright. So right now. Okay, water pump is off. Here it is. Little bit of corrosion on the impeller, but otherwise really not a bad pump. I mean, it doesn't feel worn really all that badly. But yeah, there it is, all out. Who makes this one? Does it say? Usually they'll say like manufacturer name or something on it. But yeah, I'm not going to reuse a pump that's been in there for 25 years when I have a brand new one in the box. Where is that thing anyway? Yeah, here it is. Now that's the belt. Pump is right here. There's our new belt. See, the new impeller is a cast part, so that's kind of nice. This is made by Gates. So let's get the seals ready for that. Pop that in. This water neck right here, I took off in place because I didn't want to remove it, but I probably should have in hindsight. Well, anyway. Just that it's hard to get to. It's just buried in there. So, I didn't want to take the power steering pump off. I mean, I'm already getting into this car more than I wanted to, but, you know. Okay, water pump is installed with nice fresh seals on the block and on this water neck. Torqued to about 15 foot-pounds. Ready to go. We're now on the assembly phase. Now let's pop out these seals on the cam and crank and get those replaced. I'm going to be using a Lyle seal puller. You can usually find these in the auto parts stores. This is a little more elaborate than the one my dad uses, which is a very simple tool that he's had forever. This tool is supposed to lock into the lip of the seal, and then you kind of nudge it out like this here. Never actually used one of these, not this style anyway. Kind of a learning experience for me. I've never actually used this exact tool, but it shouldn't be that difficult. Alright, so I think what you do is you get the tool into the seal lip like that. And you do something like this here, and then you gotta pull. Yeah, there it goes. You kind of go around the seal. You don't want to do it all in one spot. No need to pull the bearing cap or anything like that. So that's the idea. There we go. And that's one out. Let's get the other one.
You know, I have to say, this is easily the best seal puller I've ever used. My father had a couple of older style ones, and they're like, they still sell the type that he has. It's like a little hook that kind of digs into the seal and you roll it back. This one here, I really like how this one works. I got all three seals out in just a couple of seconds. And that was when you buy at any auto parts store, they have them, and it works very slick. Alright, now driving the seals in, I highly recommend buying a proper seal driver. I used sockets to drive them in, and it didn't really work that well. I wasn't happy with the results. But in the end, they went in just fine, and they don't seem to leak, so hey, I guess I'm okay. But if you're going to do the seals, I do recommend getting a proper seal driver. I know that the Flying Miata crank holder tool can also be purchased as a kit with the camshaft seal drivers, which are just machined collars that help bring the seal in just to the point where it needs to be. Never overdrive them, never drive them in too far, because you can actually block oil ports by doing so.
Okay, we're one tooth off on this cam gear, but we're almost there. I'm going to take the tensioner back off the belt. Yeah, I know I skipped a lot of stuff here. Take the tensioner back off. I'll roll that cam back by one tooth, and I should be good to go. We'll be in perfect time. Should be good. Those two red painted marks are where I left them. They should be lined up with those two marks in the rear timing cover. And the two hashes on the top are the 12 o'clock position. Yeah, exactly. So, crank is still at TDC. So this sucker should be good to go. So I guess reassembling is yeah. But before I do that, I'm going to swap out a bunch of hoses. All right, I'm going to retorque the crank bolt to 120 foot-pounds. Now, one of the forums said to put Loctite on this bolt, but there was no Loctite when I took it off, so I'm not going to do that. Hopefully that's not a bad thing. So this is going to be interesting. Alright, position myself. Here we go. I can't get it. There we go. That's it. And we make sure that we unload the torque wrench when we're done with it. That way you don't give the spring memory. And I didn't dent any body panels either. Sweet. Okay, I've reconnected the battery. Now right now we have no accessories connected. I've got the intake pipe on just so it'll run. But I want to see this thing run before I start buttoning up the cooling system. So we're going to run it for a few seconds and evaluate it and see where we're at.
And before I attempt to start this motor, if I had an interference engine, what I would be doing first is manually, by hand, rotating the crankshaft enough times to give me 4 compression strokes. That way I know there isn't any binding and the timing belt was done correctly. But I'm confident in my work, I'm pretty sure I did the job right, and it's a non-interference engine, so I'm just going to go ahead and try to start it just to make sure everything is where it should be and that the engine still runs. But yes, rolling the crank by hand is usually the first thing you want to do before hitting that start switch or ignition switch.
So it's acting like there's a sensor problem right now. So let's just double check our electrical stuff. It actually is running. It must have something unplugged. Ah, I've got this disconnected here. That'll do it. Okay, now I'll try again.
So the misfiring problem that I had turned out to be another vacuum leak, but we'll fix that in just a moment. But I want to talk a little bit about starting an engine after the timing belt is done, but before the cooling system is filled up with coolant and all the other components are added. Basically what we're doing is installing the minimum components needed to make the engine run smoothly. That's what we're doing because we want to hear the engine run before we start filling it up with coolant and other bits and bolts and belts and what have you. It's much easier to fix a problem at this stage without the cooling system filled up than it is if we had already done so. So, is it okay to run an engine without any coolant? No, it's not. But if you're starting it up just to hear it run for a couple of seconds, you won't hurt anything. Remember, the water pump doesn't even have a belt on it yet, so it's not even running dry yet. It's not even turning. So there's no issue there. We just ran it for a couple of seconds. We found a few vacuum leaks. We fixed the vacuum leaks. We started again, and we're good to go. That's basically the long and short of it. At this point, and yeah, the other benefit, by the way, of doing this without any accessory belts hooked up is that you can hear the engine singing solo. You're not hearing the belt noise. You're not hearing the pump noises and the alternator. You're just hearing the engine sing. Speaking of, let's do that right now. And I heard everything I needed to hear. The engine sounds great. It's running smooth as glass. And I think it's time to start putting it back together again. You can see a little bit of steam coming out of that thermostat housing port. And that's only because the cylinder liners have started to warm up a little bit. And whatever wetness was left is now burning off. But things are good. I think this engine has a long life ahead of it. Let's button this sucker up and get her out on the road.
You know, there's something to be said about working on air-cooled vehicles like Volkswagens. Seriously. This sucks. It's a terrible job to do. I'm doing all the hoses on this car, and as I look at some of them, I'm glad I have made that decision. No regrets about that. There we go. I'm using original equipment hose clamps, same ones that they use in the factory line. And these are actually very nice to work with when you have room to work with them. All you do, they're spring clamps, and they're color coded by size, and you just pop the retainer off and clamp springs into position permanently. Of course, you can always release them as needed. But they're hard to get to. Well, this is the one hose that I just really didn't want to do, but when in Rome, you just pop these off and the clamp springs into position. That's all. Just getting them off sometimes seems to get bare because you have no room to work, and we're just talking in circles at this point. So, come on. There we go. Almost. There we go. Ooh, that one hit me in the freaking head. They're under a lot of tension. That one flew up in my face. But it's in. Oh my god. That hose will never have to be replaced again. Alright. Yeah, you gotta do what you gotta do. Look, I got that hose replaced, at least the bare one to get to. So all the front radiator hoses, those are getting replaced. That's a done deal. I gotta remount the stabilizer bar. I gotta not forget to do that. Let's get the fans from the old radiator mounted on the new one. That didn't take too long. Okay, radiators are installed, fans are installed, system is filled, hoses have been replaced. Let's light the fires and kick the tires. I'm gonna bleed that radiator. better than it's ever sounded before. Do some gurgling.
Now you're going to hear a lot of stuff about bleeding a cooling system. Fortunately, most 4 cylinders that I've worked on so far have been very easy to bleed. In fact, they just do it on their own. The highest point of the cooling system is the radiator in this car, and there are no other bleeding points on this motor. I find that some V6 engines and V8s, they require special bleeding techniques, but this one, you just leave the cap off, let the engine do its thing, and just keep topping it off before it reaches full operating temperature, because if you leave the cap off once it reaches full temperature, it'll start bursting coolant everywhere. You don't want that either. So we're just going to keep adding coolant as needed until it's totally full. There's no more gurgling or bubbles coming out. And we're also going to drain and fill the overflow tank as well. Now how the system works is during normal, once it reaches operating temperature with the cap in place, it actually lets out a small amount of coolant as it expands into the expansion tank, which is on the passenger side. And once the vehicle is parked and cooled, it'll start to cool. The coolant will begin to cool down, and it will shrink, or it will condense, so to speak, and it will start to draw coolant back into the system from the overflow bottle. So that's why it's important to have a full overflow, or a properly topped off overflow bottle. That way your system never runs low on coolant. Well, I'm happy to report that while the video footage is 2 days old, the voiceover that I'm doing is from the future. So how's the car running? I've been driving it around for 2 days straight, and I have had no issues, no leaks, no funny noises, nothing. This is probably one of the easiest timing belts I've ever done. And I say that because it's a front-wheel drive car, and once you get that radiator out of the way, everything is accessible and exposed, and you can do whatever you need to do without hindrance. As I'm pointing out in this video, I did take the coolant overflow bottle and I rinsed it out, actually flushed it out, cleaned it thoroughly inside and outside, made it look brand new again. I got a little smudge on the fender there. But no, seriously, I would give, as terms of difficulty, this is one of the, other than an 8-valve Volkswagen engine from the 80s, this is probably one of the easiest timing belts you'll ever do. And one of the good things about this engine, like I said previously, is it's a non-interference engine, so the stakes are low if you screw up. As long as the engine runs smoothly, you basically did the job right, and you should pat yourself on the back. Congratulations. You know, they say practice makes perfect. This is not my first timing belt. This is like my 3rd or 4th. And I gotta say, it is a very easy job. And again, what makes this job a little expensive, though, is there's a lot of stuff you want to do on an old car like this while you're in there doing a timing belt. Hoses, seals, you know, all those things should be done on a car that's almost 25 years old anyway. But when you have all that stuff removed, just go ahead and do it. The job in total cost me around $670, and that's because I replaced everything. So enjoy, have a great day, and if you decide to do this job on your own, good luck. I think you'll do just fine. Until then.